I'm a big fan of how they have it divided into like subcategories, and you can kind of delve for depth in one of those categories, like embedded, for instance, or algorithmic, or you can go for breadth and kind of get this really big cross section. There's a lot of representation of people in different skill sets within C++.
Hello? I think everyone can hear me just okay. Hey folks, thank you for coming to my talk. Today we're going to talk about LLMs and how to apply them for system programming. My name is Todirel. So I was thinking quite a bit about how to structure this talk and what would be the best way to kind of present this. So I was thinking like it wouldn't be very fun to start from the talk and try to find tasks that fit in the talk. So instead, I actually took a real-world project that I worked on, that I built from scratch, and for which I know I apply AI and solve different tasks. So that's kind of what I want to show you today. So in terms of agenda, we'll do an intro. I'll present you the project. I'll show the project to you. And we'll go through several tasks and show you how I apply AI. And based on that, we'll look at the solution. We look at successes, opportunities, and we're also going to talk about lesson learned. So just a little bit of intro about myself. I'm an engineering manager at Microsoft. My team is part of the C++ organization. Our group owns the Microsoft Visual C++ compiler and the C++ developer experience in VS and VS Code. C++ is my favorite programming language. I mean, I'm here, right? I also put that on my badge. So if you find me, ask away what I love about C++, and I'm going to ask you the same thing. My very first C++ conference was going native. This was a C++ conference back in 2012, 2014, maybe. And from what I understand, CppCon actually evolved from those ideas. I'm very hands-on. I love building hardware and software at home by night, sort of speaking. I like embedded development because I like to see software running in my hands end to end, but I actually don't like embedded development from kind of constraints and limitations that you have to work with. Power electronics is one of my hobbies when it comes to electronics, so I kind of love that. I'm also a ham radio operator, and kind of love that because it enables me to fuse software and hardware together, and I think like you can spend your entire life just in one of the areas of ham radio. I got my FCC license in 2022, and APRS is one of the digital mode that I love. Microsoft has a pretty big presence at CppCon this year. We have some super awesome, fantastic talks. If you folks haven't had the chance to do it or check any of them yet, highly recommend. We do have some prizes. I recommend taking the survey, and maybe you win some of those things. Cool. So before starting, I just want to ask, raise your hands if you're a ham radio operator in the room. 1, 2. Wow, OK. Not as expected. How many of you folks are using AI tools today? Wow, that's fantastic. Half of the room. And how many of you folks are building AI tools? OK, not bad. Cool. So I want to introduce you to the project and kind of talk about the tasks here. So this is what the project is. It's a repeater and a tracker. It's built completely from scratch. So every single part about the hardware, about the design, including the software, it's built as part of, well, not part of this talk, but part of the idea behind this talk. So the idea behind the repeater, you can think of it, if you're not a ham radio guy, you can think of it as a cell tower that extends the range of internet or data. And then the tracker is something that tracks position. So think of Find Me, right? You can look on your phone and you can see where you are. So this is the idea behind this. This is fully off the grid, so it means it works because it leverages ham radio as the communication link. No internet, no infrastructure. You can run it quite long, pretty much worldwide, depending on conditions. You can do it on 2 meters band and so on. And this is also a very small design. It can fit in your hand. I actually called it Matchbox because it's the size of a box of matches. So that's kind of the dimensions for it. And it's handheld and battery operated. Here's the hardware that I designed for this. So it's made of two boards. The main board hosts the data modem. So this is an FSK modulator, the modulator. And then the data board holds the repeater and tracker. So this is the PCB renders for that. This is the main board architecture. The core of it that runs the modulator is the modulator is the DSP33. Uses a lot of its DSP to do that real time. And then this is the hardware architecture of the data board. The data board is basically the ESP32 MCU because of its wireless capabilities and the main peripherals, the clock, the GPS receiver, and the environment sensor. Everything else is just power electronics. And then super high level, we're going to focus on the repeater and the tracker. This is how the stack looks like. So we have our hardware, and then this is kind of layered from the, converting the binary data into talking to the modem into text and decoding or encoding in the case of the repeater or the tracker. So we're going to talk about the tasks now. So this is kind of what I want to get through today and show you each of the tasks and how I solve them, how I leverage AI in solving it, what's the solution, and what are the lessons. Fun fact, all of those icons were generated by ChatGPT, pretty cool. And I'm going to use it through the talk kind of to mark different pages, whether this is about code or about the tasks or about the goals or about the solution or about the lessons. Before we drill in, I just want to talk about sort of AI tools that I typically use myself. So this is framed not in everything that's available to you, but in everything that was relevant for me working on this project. So I find myself mostly using the chat interfaces, whether it's VS Code or ChatGPT or Claude. So this is the interface where you go type a question, you get an answer. You don't like the answer, you add a comment. You keep iterating and you keep going and going and going. There's also chat interfaces with development context. So if in the case of the web chat interface, you go there and you get an answer, a chat interface integrated in your editor or IDE can take that code and patch your files as an example in the most simple examples and make changes. There's also different integrated AI features. For example, when you fly docs, you can hover over a function and get a comment or a context about what that function is doing. Completion is super useful from a productivity point of view, so I do use those. Chat and agent mode is something that can execute additional tools to verify answers, so that's also super useful, and then agents in general. So GPA planning. So this is an ESP32E. The official name is ESP32 Vroom 32E. So this MCU has 47 pins, 12 are ground, 7 are unconnected. 4 can be used for GPIO functionality, but in only, no out. And then 6 of those are strapping pins, meaning they kind of serve a special purpose, and usually they should be avoided, because if you don't, your MCU might not boot. So lots of pins to work with, and some constraints. So based on the architecture of the hardware that I showed and the peripherals that we have available, this is kind of what we need, right? We need some GPIOs to interface with the modem, to detect when a packet is incoming, to interface with the power system, to turn the system off, like soft power off. We also want to have some I/O, like LEDs. We're using all of the serial interfaces to interface with the modem, to interface with the USB interface, and the GPS receiver, as well as flashing, so we can program the MCU, the ESP32. And then one I2C interface is used for kind of everything else. So a prompt for this kind of looks like this, right? You're starting with, okay, I'm using that ESP32 Vroom 32E. This is the plan I have. This is what I need. Give me an allocation. What pin should I use for what? So that's it, nothing more, nothing else. And that works quite well. And we'll look into some of the issues there and some of the learnings. But ultimately, with a few iterations, this is what the plan was from AI, from an LLM. And it works. I implemented this on hardware and everything is cool. This doesn't match exactly what the plan from AI was, because there are additional PCB-related constraints that have to be applied here. So for example, one of the peripherals could be too far lower, and it will take too long of a line to route it. So in that case, we don't want that. So we want to use another pin. But either way, this is kind of how a GPIO plan looks like. Also worth noting that the descriptions are human-generated. Everything else is AI. So the cool thing about this is that just after a few iterations, the plan was complete and it was matching exactly what the final plan ended up being. It was pretty cool to see that the enable pin of the ESP32, there was a remark done by the AI that that's a special pin. You have to have a pull-up resistor. You also have to have a capacitor to ground. So that's kind of cool. Those microcontrollers are kind of system on module, especially the ESP32. So they require very little external components. So this is kind of the only thing you need to run it. It also identified the GPIO only pins. So it said like, hey, if you need that, this is the one you should use, because you're gonna run out of the ones that you need to output a signal. It also identified 3 of the 4 bootstrap pins. So some of the opportunities and areas where it didn't work so well. So some models only identified that the GPIO36 is a GPIO input pin, meaning that it thought that everything else can be used as input and output. Not all models, just some of the models. It also consistently said that WART0, that's the serial port used for programming, can only use for programming and nothing else. And actively said, hey, you can't use it for that. You have to be careful about that because it's not going to work, which is not true. Obviously, you can use it for more than programming. And at some point, it's also proposed a plan that required 4 warts. So it thought there are 4 warts available, and there aren't. ESP32 only has 3. It also suggested a pull-up for GPIO, which is really bad, because if you do that, you won't be able to program it. That pin has to be left floating. Beyond that, it also suggested at some point some GPIOs that don't exist, that either not connected or they don't actually, there's no such GPIO. And in some forms, that module also has an internal flash. So it assumed this one has it and consistently said that, hey, 4 pins are actually not available to you because you have them connected to flash. So in my case, that wasn't the case. So some of the lessons for this task is that what really worked best is to take a picture of the module, the one that I showed them earlier, and put it with your prompt. And if you say pins to avoid, for example, the one that are strapping pins, and if you say which pins are input only, and those are readably available from the data sheet, because it's just very early on, very well specified. It still required a few iterations, but it was the shortest, like 2 or 3 iterations. So that works the best. What didn't work the best is the initial prompt, which was, here's the part number, here's the plan, give me the plan, or here's the goals, give me the plan. On one of the iterations, we had, so some of the things we talked about, right? Like step by step, this is actually what happened. Another lesson is like, some model worked best, some model didn't, and that's not always a common pattern. So I highly recommend don't limit to one model. Because you can get most if you try the same problem across multiple models. And then the main lesson here is if you provide more context ahead as much as possible, you're going to have fewer iterations. This is kind of the schematic, like I mentioned. The system module here, the MCU module here requires very little circuitry here, so it's very simple. And then on the left there is the layout. And you can see I did the label, so that helps with documentation a little bit. So GPIO programming, one of the next tasks is, okay, I have a plan. I have my GPIOs, my pins. I want to create installation logic, but I also want to code against the peripherals and start writing my firmware. So one of the constraints here, I do want to use C++. So I want to use ESP IDF. That's their expressive SDK for native development. Don't want to use deprecated drivers. The one mentioned there are the ones that are current, they're not deprecated. And also want to interface with OpenDrain IO. In this case, this was the battery charger. So that requires a few considerations. So the prompt here is very simple. It's just, here are the pins. You can use them for just the Excel table actually in a CVS format. You can put it in the chat. Initialize it for me. And it works super quick, super fast. Everything you see here was generated by AI. In this case, it was great because I don't have to go read the datasheet. I don't have to read the documentation. I can iterate very fast, and it works. So some of the successes here: very fast to generate the code, very fast to get something working. ESP32 has good samples, but you don't have to spend the time reading the samples. It suggested the correct configuration for interfacing with the OpenDrain IO. In that case, you want a pull-up, and then when the pin is activated on the charger, the GPIO becomes low instead of high, right? That's kind of how it works. And super quick to iterate and correct all the issues. So some opportunities and some of the thing that didn't work so well. Just out of the box, you ask the question, generates Arduino code, which is something you can do with ESP32, but not something I wanted. Very nitpicky there, but there's a few ways to generate GPIOs. One of it is using the GPIO config, which is high level. I wanted the lower level functions, not a problem. And just you say that and it corrects it. It left pin floating, and also it didn't use the GPIO mode input and output. The reason that's kind of important is because if you use a GPIO as an output, it's kind of useful to read the value, and if you don't set it as input-output, you cannot do that. This is useful for debugging. It also didn't fully initialize the serial interface, and that generated multiple compile errors. The core problem with that one was aggregate initialization. Like if you look at the data structure there, if you don't, for C++, if you don't specify one of those fields, you can't compile it, right? You have to initialize everything. It also recommended deprecated interfaces like driver I2C instead of I2C master. And if it works, but you do get a compile warning, not an error, that's deprecated, you should use the new one. The other opportunity here is that both ChatGPT and Claude in this case have a web code editor, and if you look into it, you can see the response instead of in line. You see the whole code kind of projected on the left or on the right, depending on how they configured. So that doesn't work so well because sometimes gets out of date. So you might be fighting with the prompt asking, hey, that's actually not what you put in line, and it's not actually what's in the editor. So I usually don't use it and avoid it. So in this specific case, this is a good example where agentic mode can help, because the 6 iterations I had to fix the word config structure initialization error could have been done by an agent, iterating on every time, keep doing it until there's no errors, right? So that's kind of an awesome example where that can help. And then 4 iterations for the driver I2C master, that's just warnings. So another example where it could have helped if you had access to the build output and you could put that on a prompt. This is also an example where I don't know if it makes sense to iterate a lot on the prompt because the initial code was fairly fast. So it might be actually faster to go fix your errors than ask the LLMs to fix it for you. And then the code editor, I have a tendency of just saying, no, don't use it. I'll always get my code in line because I've seen rendering glitches, I've seen changes in the chat that don't match the editor response. So this is the lessons. The next task we're going to look at is how to make some of the C++ libraries embedded friendly. So these are, for prototyping purposes, those are 3 platforms I highly recommend for prototyping. In this order specifically. The reason for that is because they have an awesome developer experience, especially the Pico. So highly recommend that. So I have 2 core libraries. One, it serves as the core repeater, and the other one, it's the tracker and the packet encoding. So when I developed those libraries, I developed them on desktop platforms, on Windows, on Linux. I developed them as header-only libraries. And I only have a small dependencies on a subset of C++, so nothing external. So that's kind of where I started from and what the task is. What I'd like to get out of that is I'd like them to run on ESP32. I'd like them to run on Raspberry Pi Pico for developer purposes. And it will also be nice to run on Arduino and PNC. I like to have control over heap allocations. It's okay to allocate at the beginning of something, but if you iterate, like if you run your router or repeater, I don't want to be surprised by allocations there in that loop. There's not a hard throughput requirement. Ham radio links are usually quite slow in terms of speed. So in case of, in this case, APRS, it's usually like 10, 12 packets per minute. So there's multiple optimization opportunities. One is I'm kind of handling genome parsing, so that's something we're gonna focus on. And then the router has to handle a lot of address comparisons, and that's another area where we can optimize and eliminate copies. For purpose of time, we're not gonna look into the other ones. So this is an example of a function that takes an enum as a string and just returns the enum value. The version on the left is the first handwritten version by me. Not very well thought out. It is a map, not efficient. Kind of makes sense, you cache the map, but not the best code you can come up with. So you can make a prompt, put this function, just this function alone, nothing else in the prompt, and ask, hey, make this function faster or optimize it for memory usage. And that's kind of the response from the first prompt. So what it did, which kind of surprised me, was it sorted out of the enum fields and stuck them in a static array. And then it used lower bound to find one of the enums from a string. It's pretty cool. It also used string view. I think this is a very cool example of string view. It's quite profound because you don't depend on a container. You can initialize a string view from anything. Could be a literal, could be a heap allocated container, doesn't even have to be a string, just a byte stream, right? So that's kind of fantastic for embedded because you're not constraining against something that is located on the heap. So it's quite flexible. The second iteration, if you keep asking, hey, is there a better option? Can I make it faster? That's literally the second iteration. And I actually didn't think of that. If I spent more time, I'm sure I would have came with the same answer, but I didn't realize that all enums start with QA, so you actually have to compare just one character, and that's super fast and efficient. You don't have to think about anything. So that's fantastic. Very fast too, like took under a minute. So when it comes to optimizations, my experience was that if you take a function and give it to AI, you always get some interesting insights that you can immediately apply. So there's always opportunity there. The human me here didn't recognize that could be optimized much better, and that all enums started with QA. And then all the answers in this case were good and safe with minimum iterations. So that was fantastic. And all of the answers from one of the models, only one of the models, I'm not going to call it out, there was a bias against STL, and it constantly said, hey, don't use std anything. Use the answers actually contain const char and pointers and so on, which kind of surprised me. So that was interesting. And then one of the answers used a hash of the string and had a quite complex and unreadable solution. Address comparison, this is something that the router has to do a lot. So a call sign or an address is broken down onto the other data structure that is presented on the left and contains multiple informations like, how many hops remaining or how many hops requested. That's the lowercase and the uppercase n, or what's the station ID. This is needed because you wanna create something higher level that you can, process very fast and not deal with strings anymore. So a comparison there to check if two addresses are the same has to not account for the used field, which is a star, right? It's the mark field. So the code I had was this: you convert to string both addresses, and you remove the used. This is because an address could be a call sign, or it could be a path constraint, like in the case of wide 1-2. So that means that they may be the same address, but different fields in the address data structure are gonna be set. So this is what was the toString function that we saw earlier. This is kind of the first version I wrote. It's quite readable. Uses toString. It's very simple. Nothing to write home about, right? But intuition kind of says like toString, I heard that's inefficient, especially when dealing with numbers. Maybe that allocates memory, maybe it doesn't. And also concatenating strings, right? Like, is that efficient or not? So the first iteration from AI, if you take that function and make a prompt and ask, hey, make this function faster, was this, which is actually quite good. So it reserves the maximum possible string size at the beginning. That happens to be 16 characters. And then because we have a constraint on the n and lowercase and uppercase, that it's from 0 to 7, you don't need to do anything fancy. And then for SSID, ID, similarly, like you just extract the numbers and you don't have to use any conversion there. The second part I wanted to focus on is, can I avoid converting the addresses to strings and completely bypass the string function, So this was kind of my initial attempt. I kind of count every single possible case in each of the addresses. So this is like a pretty big function. What you see here is just half of it. And difficult to read. It works, but difficult to read. This is the first iteration, which actually surprised me. So what it did was just normalize the addresses to make them the same, regardless of whether you're using the SSID or using the n and n numbers. And just after normalization is just a simple comparison. So that's kind of awesome. Something that I didn't think about. Much easier to read, and this is the entire code. So successes. Correct solution with good durability, nothing surprising there. What was interesting is that my toString function is actually faster than the one that you recommended by AI, where you reserve the memory at the beginning, the string, and then you just subtract to get the character. So this is an example where, again, if we had a test that measures performance and can print the result of the run and the STD out, an agent could read that, and when it generates the solutions, it can keep running that test and self-verify against the solution. So it could as well come back and say, your function is as fast as it will be, no solution. The other interesting thing was the solutions are unpredictable. And if I remember correctly, GPT-4, the very first answer was the one with the sorted array and the lower bound. And on GPT-5 and on cloud, it's different. So the models are continuously updated. What you got in the past might be different today in terms of answers. So lessons, best programming models aren't best for everything. One of the models suggested a very complex hashing solution with a const-char interface. Const-char is fine, but not in the context in which it done this. Also, in every iteration, I kind of had to fight against warnings suggesting that STL should never, ever be used on embedded platforms. So that's also kind of interesting. And the models are obviously non-deterministic. I mentioned, like, in one case you get one solution, in another case you get another solution, even from the same model. The other lesson is that when you're dealing with performance, you can't assume the answer you're going to get is going to be the best. What intuitively seems faster, it's not going to be. You have to measure. That's obvious. Performance tasks, I think, are pretty good for agentic tools because you can iterate on them and have the agent try until you get the best solution out. And also felt like for the function that was comparing addresses, it's a pretty big function. It's about 200 lines because a lot of it is comments that I hadn't written to explain and document how the comparison works. And I felt like that really helped the model in coming up with the normalization because it just had that much context. In my case, I didn't have a very hard job in converting the libraries to run on embedded platforms. I think embedded platforms have come a long way. You can do heap allocation. You can use even exceptions like on both on Pico and ESP32, which is kind of crazy to think on such small microcontrollers. So I think if you're using the standard library, depending on how you're using it, you may already be there and having your code portable for embedded platforms. Okay, UTF support. So this is what a packet looks like, one of the packets. So we encode a lot of information in there. It's a position packet. We have information like latitude, longitude. We have an icon. The icon is a lookup on a table. That's why it's only 2 bytes. We have the speed. We also have the routing path for the router. And we have a message. So the message part of the packet can be UTF-8 optionally. Usually it's ASCII, but can also be UTF-8. But only that part, nothing else. So in the initial design, I was thinking kind of classic thinking. I'm going to store internally an UTF-8 string, and then I'm going to convert different string types, whether it's, say, UTF-16 into UTF-8, and then similarly, in returning the data out, when I encode the packet, I'm going to transcode it, right, from UTF-8 to wherever the ask is. So that also means taking different string types as an input. So classic ones, double string, U8 string, std string, and then using code CVT to convert between types. And then I kind of evolved this, and I'll explain how in just a second, to kind of thinking about, like, I actually only need this for the message. And I'm not actually rendering this anywhere, so I don't need to have it in any specific encoding. The modem actually consumes an array of bytes. It doesn't care if it's a string or not, right? It's just bytes. So the final solution included, it's just for everything that it's encoded, and ultimately it's ASCII, but it's encoded in its different formats. I'm just using string and string view, so string view as an input and string as an output. And then the message is accepted as different types, and it assumes whatever the input encoding was, that's what we're going to go with without any transcoding. And then we store the message as an array of bytes. And then when we want to encode a packet and return it, we just return a sequence of bytes and just append the message at the end of everything else. This is how it looks in an API. So there's different ways to set a message. So you can set it as a UTF-8 string literal. You can also set it as an array of bytes. And then if you want the packet encoded as a UA string, you can just call that function UA packet string and the packet type, and you get it as a string. But really what the modem is going to use is the last overload, which returns it as an array of bytes. So different ways to set a message, different ways to get the encoded packet in whatever format you want, and no transcoding involved. So what was kind of cool, I wasn't super familiar with code CVT. It was when I asked, I got an UTF-8 string, encoded string, and I want to return a UTF-16 string. Code was good, functional, compiled. But what was also a shock is that very early on, every model recognized that code CVT is deprecated in C++ 17 and removed. And I didn't pay very close attention to that. And then when I saw that the design is not going to be the best and it's going to be sort of a monster to figure out, and I need to go with something else, I took a step back and tried to read what the model said. And honestly, it was quite a bit of a shock. Like, code CVT has been in the standard for quite a bit, and it's not anymore at all available in C++ 20. So I think like that's amazing that a model can just tell you straight out that don't do that. You might have it from your compiler vendor, but it's probably not something you want to focus on for the future. ICU is a fantastic library. It's kind of got everything you can possibly need for encoding for Unicode support. But I didn't want to take an external dependency. But I played a little bit with it, and the code that it got back was fully functional. All worked fine. So that was definitely a success. And the other cool thing is that with just a few iterations, AI can build it to the best solution. So I try to walk back and ask, hey, here's what I'm trying to do here, right? Only the message is the part that is UTF-8. Everything else is ASCII text. What's the best design? And it kind of came with a similar design that I have in mind. A few opportunities. Some of the earlier models, like GPT-4, didn't immediately recognize the codivity is deprecated. So that's definitely something that has been, I would say, fixed, because I haven't seen that taking more than one iteration. And then it also suggested to use multi-byte to white jar and without any assumption. I haven't specified this as cross-cloud to be fair, but it assumes that I'm on Windows, right? So that's not maybe the best. Cool. So one part of the project is a tracker. And when building a tracker during development, we need GPS data. And it's obviously will be not feasible to take your laptop and drive around during the development of the tracker. So we want to visualize and understand how the data is consumed and how the tracker works as we're developing it. And we also want to tweak it so that we, using the network efficiently, this is a ham radio channel, everyone is using it equally here. And also we want accuracy, because we don't want a point here and a point there and no correlation between where you are. We also want to be able to run tests or create tests and find bugs. And obviously we can't only do that with something driving around. So what we'd like to do for this is have been able to render a map so we can see the results of the tracker. We want to generate a route from a start longitude, so that could be the position of this resort, and then the end could be Denver City, and then that's the route. We also want to generate, because speed is important as part of the calculation, we want to have that information as well. And then we want to have a GPS simulator that feeds data real-time or accelerated into the tracker. So this is kind of how you can do it. You can use the OpenStreetMaps to visualize the map. You can use Valhalla, which is an open source routing engine to generate the routes. For the GPS simulator, we can use interpolation and harvesting to know the heading and play back the data back. And then for the GPU simulator output, we can feed it into the tracker. And then with that, we can use a WebSocket server and render that to a JavaScript client. That's kind of what's happening here. We generate that static data at once. That actually happens from a Python script. We read that with the read route from file, and we get all of those points which contain lat, lon, and speed. Then we interpolate that route because we want, if you want to do it in real time, if you're going to have gaps, so we interpolate like every 10 milliseconds in this case. That's what the const was. Then we run a WebSocket server, and then we play back. We have a GPS simulator, and we play that. We feed that data into the tracker. So I used AI for this. I knew nothing about mapping, what OpenStreetMaps is, just heard about it, but not how it works. I never heard about Valhalla in my life. I thought that's just like a MCU reference. So AI was able to help with that, was able to quickly identify and find a container on the internet that can host an OpenStreetMap server. It's a kind of an amazing project and super easy to get started. Same for Valhalla. You can take the data from like GeoFabric, PBXs, I think, PBFs, I think they're called, and generate the tiles for Valhalla and run a local container. I didn't have to read documentation about Valhalla. I asked AI, hey, I need a route, a bunch of points that contain lat, lon, right? So Python script that has all of that, super easy, 5 seconds, and you get it. And then I ask a more complicated question. Hey, now I need to know the speed limits based on what's known for the map, because I want to incorporate that. I want a real simulation, as if you're driving on the road, right? So it came up with a solution. Turns out that those are represented in OpenStreetMaps as tags, additional information about segments. And there is a request you can make to Valhalla that's going to get you that information. So I really was no sweat. I got that from AI. Then based on that, easy to serialize into like JSON and then consume it. It wrote the interpolation function and harvest sign. Harvest sign is needed to calculate the heading between 2 points. And then I didn't have to read any of the boost documentation. ASIO in this case, this is for timers, for running timers. And then for the web socket server, it identified a pretty awesome library, actually, Civet is the name, that can, with minimal code, run a server. And then it's amazing at Python and JavaScript, HTML. So the client was super easy to iterate on. So some opportunities here. It was very difficult to have a complete GPS simulator design coming up straight from AI. It completely okay with doing interpolation, completely okay with all of the other aspects, but having a complete implementation that follows an interface, you run it, and it gets you the points, didn't work no matter how many iterations I tried, no matter how many models I tried. And on this more complex task, the initial code was also not very readable. So some of the lessons, LLMs are scary good at Python and HTML and JavaScript. Maybe that's grounded in the fact that there's just so many examples and documentation out there for those languages, for those tasks. Python scripts, absolutely nothing to complain about or write home about. They were complete pretty much in the first iteration. And then JavaScript, HTML, CSS, OpenLayers is the library that is used for rendering the map. And interfacing with the map, also super easy to iterate on. The actual problem of creating the GPS simulator didn't work so well. Seems like when you have a complex problems, from multiple subproblems, maybe just you don't have enough memory or something, but you can't complete the task completely. And then another lesson is that depending on the task, the code readability may not be that good. And this is a demo of this working. So I start with project, in this case is Open Visual Studio. So each of those points are the GPS simulator points, and the crosses is when the tracker decides to transmit, right? So you can see we don't actually have to do that often because we're going in a straight line. So that's one of the optimizations, right? Why would you utilize the channel and spend time when you're moving around if nothing is contributing to the accuracy of your track? So this is kind of cool. Something you can do when you have a setup like this, where you have the simulated points and you can feed that onto the tracker. Cool. And then the last task we're going to talk about is finding USB serial ports. So the main board has a USB interface and a USB to serial interface. So one of the tasks is that we want to automate the testing. We want to containerize the system to run the repeater. And we want to do that probably in a container. That's kind of my default approach. To be able to do that, we need to find programmatically that port. And you might have more than one of those boards attached to a system at the same time. So how do you know which one is which? Because I'm running containers, this is a Linux-only solution, because the containers have to have access to the hardware, in this case, the USB interface. And I also didn't want to change anything on the system. For example, you can accomplish this and this mapping with udev by having a bunch of configuration files on Linux, but I didn't want to change the system configuration. So here's some of the tasks. We want to enumerate serial ports. Turns out udev is the tool to use in this case. We want to extract various port information, hardware information from the port, like the name, the serial number, the description, manufacturer, the hardware path. And then we want to identify what's unique about each so we can map it, right? So that's kind of what the final interface looks like. We have a function, serial ports. returns a vector of serial ports, super easy. And then we get a description of each one of the ports. And then the tip you see over there, it's the Visual Studio Debugger kind of prints each of the properties of the device description in this case. So I really didn't know anything about Linux system programming at this point. This was like maybe 2 years ago. And it was kind of awesome to me that I could ask, hey, I need to find a way to find serial ports, and models came back and said, hey, UDEV is something you can use. And it's not just something that sysadmins use. There's actually a library that you can use and program against. So it was super easy to generate code to query the device manager on Linux and get each of the serial ports. It was very easy to add filter queries. So if you know the manufacturer, you can put a filter and get all of the ports with that one manufacturer only. And then very easy to do JSON serialization. So if you put this out, and that's your interface, programmatic interface between the system that finds the ports and your container, for example, that's a good way to do. So like that's super automated way to use an LLM and get it. What it didn't do so well is it doesn't quite know what UDEV property matches against what information you're trying to retrieve. So for example, you might not know that serial is actually the property name for extracting the serial number for a port or the product. So quite a few hallucinations there. But that's something you can iterate on. There's like tools in Linux that can get you the hierarchy of all of the properties, and you can iterate quickly on that. So not a big deal. So kind of almost at the end here, conclusion. I think LLMs are super useful in the prototyping stage and early design, and it can really increase productivity by a lot. I'm the example of that. Like I don't have a lot of time to do this kind of things. I sometimes do it in the evening, sometimes I do it in the weekends, and I was able to make significant progress very quickly. I don't want to put a number on it because it depends. I could say 2x or 10x, doesn't mean anything, right? I do think there's a lot of boilerplate, whether it's about writing boost code or generating serialization code or generating low-level GPIO initialization. We have a lot of it in C++, and LLMs I think it can help with that. Also, I don't think the LLMs answers have to be perfect or complete for them to be useful. I hope there's no vibe coders here, but we're all quite competent and we can take a solution even if it's imperfect and iterate on it. Some iterations can be long, and I really believe that agents or chat and agent mode, for example, can help and shorten it by coupling the questions and the queries to tools that we run. In my experience, like they've been getting better. I've been using this for a few years now, and some of the answers surprise me, especially when it comes to performance optimizations. I do think that you have to be a good designer to use them effectively. So if you're early in career or starting up, they can help, but they may not do the most for you. And this is a personal opinion, of course, but I'm not convinced that better prompts can compensate for limitations, like, for example, avoiding hallucinations. We are at the end of the talk. This is just a graphic. Just want to get to Q&A now.
Hey, thanks for the talk. I just had a question about the tracking mode, because this is all over HF radio essentially, right? And so were you localizing the thing being tracked through like the radio signals, or was that being transmitted through the HF?
Got it. So the question was maybe who listens and how can you actually take that position info and put it on a map, or how do you actually consume it in a way that is meaningful to you? So the digital mode used here is called APRS. APRS stands for Automatic Packet Reporting System. So some of those repeaters on the network take that information and put it to the internet. So there are websites that can take that out of data because there's a radio interface to the air, right? It listens, decode the packet, extract the latitude, longitude, speed, and then put it on the internet. And there are websites, for example, aprs.fi. If you go there, you're gonna see all of the traffic that's coming from ham radio. So you can do it like that. You obviously don't need the internet. You can have a local system that just takes all of those packets, decodes them, and maybe runs OpenStreetMap offline. You can totally do that too, right? But that's kind of how it works. So you basically control, that's the cool thing about this, how you want to interop and partake in all that information. Maybe that information means nothing because it's just in the air and no one does anything with it.
Okay, thank you.
Great talk, thanks. You mentioned like not having to read documentation or sort of getting a creative inspiration from the LLM or maybe some other things. Where do you think, if you had to like bucket the benefits of using LLMs through this, where do you think they mostly fall for you in this project? Does that make sense?
Yeah. So the question was, what is LLMs most useful, and is it only to get around not having to read documentation, or are there other parts where they're useful? So this project is quite complex. I still have a lot of work on it. I will say the way I think about it is that anything an LLM can help me with to elevate my productivity and have to let me think less about things I don't care about, I think that's a fantastic win. And I've seen that across the board, from generating boilerplate to things like even completions, right? Like you have a class and you need the typical, move construction and so on. Like, why should I write that by hand? Completions just generate that for you in one go. So I don't think there's one way or another. I think it's very spread depending on what you're doing. And the point is that it definitely elevates you and makes you into a faster, better designer or programmer.
Can I ask a follow-up?
Yeah.
Did you have to spend any time like sort of debugging the language model solutions, or do you think you're...
I got it. So did I spend any time debugging the language model solutions? I will say that I'm always debugging code. Like I'm a perpetual state of debugging. I never stop not debugging. So from that point of view, it's really no different between using a debugger or not, because I'm always using it. So with LLMs, I won't say it's more or less. Okay. In fact, I will say less because most of the solutions are actually kind of complete. Oh. So they just work and you just run and it works.
Okay, thanks.
Hi, good talk on this. I had a question. Were you iterating like inside Visual Studio Code, or were you iterating mostly on the web, especially when it comes down to like the ESP32 frameworks? Because like in VS Code, you could use, I don't know if you have used it or not, like Platform IO, right? That supports the various hardware. Was that suggested by the LLMs or not?
Got it. So the question was what tools I used most, especially from the angle of ESP32 programming, what tool I use. Very good question. So from the angle of, forget about who writes the code. It's the LLM or it's myself. How do I target the ESP32 platform? I personally use VS Code. Espressive has a pretty awesome extension in VS Code. I don't know how it's called. I think it might be ESP-IDF. I don't really know. That's what I use. It's a great extension, great developer environment. Type your code, compile it, and flash it. Everything works. So that's what I use. In terms of what AI tool I use most, I will say whatever gets the job done. I use everything from VS Code, Cloud, the web client, ChatGPT, the web client, Ask Copilot and VS, like anything that gets me to complete my task. Like I'm indiscriminate in that respect,
Right. But when you, do you see any advantage from using it inside the IDE versus on the web? Because on the IDE, you have all the models as well, right? And you can also now start farming out agents. And did you play with like having different agents for different things and like maybe giving them like a code checking or one writing a test? And can you talk about that a bit?
That's a very good question. I think there's nothing in the web that's not in the editors or in the IDEs. It's the same interface. it's a personal preference. I did use chat and agent mode, and I did have the chat and agent mode verify the code for me. So the way the way that looks like, you're asking for a task, for example, generate me a serialization function using the popular JSON library for C++, the high performance one. I forget the name, but that one, right? So like take this data structure, serialize for me, generates the code, and I'm also saying, hey, ensure this compiles. So what you actually see in the response, here's the code, here's the command to compile, looks at the std output, and does that. More so the tests. So for example, for the performance iterations that I showed, I actually had it run the whole, I have like 300 or so tests, run every single test to ensure that nothing is broken, right? Like the addresses comparisons are super finicky. So if you don't generate the right code, like it will be infinite trying to figure out what's actually wrong in that comparison. So yes, the agent mode is fantastic for that kind of code.
Okay, thank you.
Hi, thank you for the talk. I really enjoyed it. I was wondering if you used AI to do like the hardware design, feed it in data sheets, do a schematic, PCB layout, and then the most painful part, like the BOM building, right? Have you tried to use it for that whole workflow?
Yeah, I have. I'll have a fun answer for you, maybe controversial. PCB layout is how I distress. I don't want AI to do that for me, right?
Yeah, so there's some fun parts of the job.
I think I have enough software in my life that I need some hardware. So I will say I definitely took a schematic and I ran it through the model and see what it will come up with, like review, that kind of thing. I have some stories to tell. I think they will take some time to explain, but some examples, like in one go, the model said, actually hallucinated on the whole thing. And that's because it didn't use the image, even though you attached it. So then I said, hey, you actually didn't use the image. You give me some answers based on earlier questions I asked without an image, unrelated. And I said, use the image, it used it, and it recognized the parts. So I didn't really focus on that aspect of this project, but I don't know what to say about that. Like, I don't have experience with that.
Okay, thank you.
Thanks for the talk. So those projects are smaller, greenfield, and personal projects, I suspect. Do you have recommendations? So my question is not applied to this type of projects, but more like production projects. What about security? Do you have recommendations around how to create an environment where it's safe to use those models? And I don't know if you have any insights in like what we should do to actually use this on a production system.
Got it. So the question was like, if you do, this is a pet project, right? So you can afford insecurity, you can afford flaws. If something's not working, it's not going to be of big consequence. But what if you use it on production code? I don't think there is a good answer there. I haven't done that myself, with an example that targets production. I will say that humans are ultimately accountable for their systems. AI can help, but you shouldn't bypass proper engineering processes that ensures that the code is secure, that you don't check in something that is gonna expose your component or system to something that an attacker might leverage, right? So I will say in that case, nothing changes with LLMs. It's just, if anything, we have to be even more cautious and more careful.
And how about like executing LLMs? Are you working in a VM, in a container, or you let them loose on your main system? Do you try to insulate them?
So the question was like, what about the trust between yourself and the LLM or the endpoint you're using to run? In my hobby projects, doesn't really matter to me. Like everything I show here is open source, open hardware on GitHub. In a production environment, I think you're gonna have to look to your IT department, what they have to say about that, right? And your privacy team.
Thank you.
So for the ESP32 at the beginning, when you got the pinout, how much documentation did you have to drag in? Did he find it all on the internet for the ESP32, or you had to give him context?
So the question was for the ESP32 GPIO planning, how much of the documentation did I have to look through and how much of it was on the
No,
internet?
did you have to give to the agent, right? Yeah.
Got it. The only thing I got to, I think I mentioned that on one of the slides, the only thing I had to give and the best prompt I had for that case was the picture from the datasheet, and that shows the pinout and the GPIO names and the pins, right? So that's one information.
Okay.
The second piece was which pins should not be used because they're strapping pins. And that's in the very beginning of the datasheet. It just says, here's the pins you shouldn't be using or should be careful to not use, right? Or how you're using them. And then the last piece was which GPIOs are input only, because that's something that the LLM had trouble with. So for that one, also from the datasheet, also at the beginning, which GPIOs can be used for input and which can be used for output as well. That's the only information.
Okay. All right. Okay. Thank you.
So I will say the whole thing took maybe 5 minutes for the prompt.
Wow, that's pretty good. Thank you.
Cool. I think we're done.